Yo, 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 what's up, everybody? Welcome back. Today we are working on my GUI framework, and today's topic is trying to get a sane color picker. Context is we are working on a GUI framework. This is our current state. Look, check out that sick word wrapping that we implemented yesterday. Check out this sick scroll bar we implemented yesterday. Wow, we got buttons, we got float draggers, we got that's it. We're out of stuff to demo. But I mean, this is the current state of our GUI. It's starting to look pretty reasonable. And the goal here is eventually to get to the point where we can replace IAMGUI's usage in our image editor, right? So right now we have an image editor, we can draw smiley faces, and we use IAMGUI to kind of control like parameters of stuff in the editor, right? And so what I want to be able to do is here, when I click on like this color widget in IAMGUI, it pops up this little color dialog, and I can like change the color, right? And that like has like immediate effect. I want to have something that looks like this. And what you will notice here is that when you click on this, it actually covers other widgets, right? So you kind of do like this kind of like base layout thing, and then when you click this, it kind of like pops up on top. Our widget system right now doesn't have any concept of like Z indexing or anything. It also doesn't really have the ability to like dynamically add and remove widgets. So we need to have some form of system where a widget can request to draw something on top of everything else. It's kind of like hand wavy what we're looking at, and that's going to be kind of like a nice thing to implement for like if we do like drop downs like this, it's going to have like the same thing. If we try to do like a right click context menu, right, that kind of behaves the same way. The like if you go into any application and you click on file and this stuff drops down, like all of this is going to be kind of like the same shit, right? So I think that the plan of action is to start with anything that can draw on top of other stuff, right? Add some way for a widget to request that he's drawn on top of things. And then once we do that, I think a color picker is kind of like the fun first case scenario. And it also kind of is nice because we can use that to update our demo app to be able to update like the styling on the fly, right? We could do like I kind of just like picked the colors for this stuff like out of my ass, and it would be maybe nice to be able to like play with different colors on the fly. So that's kind of like maybe the goal for the day. So let's get into it. I think it's more fun to start with the color picker than like the overlay stuff. So let's start by trying to design a sane color picker widget, and then we'll move from there into trying to draw the color picker on top of other stuff on a button press or something. Okay, I was Googling color picker. It's like, I don't know what the fuck I'm doing, right? And it looks like you kind of have like two typical styles. You have like this thing where I think that this is kind of working in hue saturation value space, and when you kind of like drag this thing, you're kind of rotating through the different hues, and then what you're seeing here is kind of like the saturation and lightness values shown on like a grid. The other version that I've seen a lot is kind of like I think Blender shows this one. Kind of this guy, right? So you have like a similar thing. You still have hue saturation value, but here you have like lightness as the bar on the right, and then you're controlling saturation and hue with this thing. I kind of like this a little better. But I was watching a Clonk stream the other day, and he was looking at like HSV to RGB conversion, and I was looking at it, I was like, oh, I don't really feel like this is reasonable, right? When you look at like the math here, oh my god, fuck off, just give me the fucking code. Like basically every time I've looked at this like HSV to RGB conversion, you see this like behavior where they have like a 6 if statements. Ah, god damn it, like here, HSV to RGB, like bum, 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 bum. Oh my god. Yeah, see, like you have like shit like this, right? If H is in this range, if H is in this range, if H is in this range, do some sort of shit, right? And it's like, why is that? Why is that? I was trying to like kind of visually understand what the hell HSV color space even is. And I think I came up with like a pretty good visualization that helps me understand it. So in Blender, if we just kind of color this cube a little bit, right? We'll start with coloring the cube, and we'll pretend that we're working in RGB state. So we won't worry about HSV in any way, shape, or form right now, right? So I think that you can just be like, give me the geometry of this thing and like slap that shit into the color. Wow, look at that RGB color cube. Except that it looks like shit for a few reasons. One, because the thing is kind of going outside of the valid range of 0 to 1. So let's kind of fix that by just clamping everything like this. Is that right? Where's like 1 1 here? Is this 1? 1 1, yeah, okay. So let's just kind of do that. And then oh, we've got some more. We got another axis to fix on. So which side is sorry. Ooh. And then I think everything here is actually maybe too small. This is hold on. This is x. This is 0 0 0. This is 1 1 1. Okay, yeah. So this is fine. Now the other reason this looks like shit is because color spaces are like pretty non-linear. So if we just kind of crank a gamma 2.2 on this fucker, now this looks a little more reasonable, right? So we have our red axis here, our green axis here, our blue axis here, and then like it turns white as we get into this corner, right? Now it's kind of hard to see what's going on inside here. So what I did last time when I was trying to visualize this was I kind of like created a geometry shader here, and inside you could just be like, yo, take this like cube and turn it into a fucking cloud, please. Mesh to volume. Yeah, here we go. Make that bad boy a cloud, which isn't very helpful in some way, but it is in other ways. So can we like try to make it so this cloud kind of fills the box at least a little bit? How do we do this? Density? No. Inner resolution size? No. There's a way to make this fill a little better. I guess we could just scale everything up. Scale relative to the cursor. There we go. That looks like the cube, the little gray cloud inside is about 1 big. Okay, now what you can do, is check this shit out. You go, points in volume. Volume, distribute, points in volume. No, wrong one. Distribute, points in volume. Fuck. Distribute points in volume. Here. Okay. Now we got a bunch of random points in there. Wow. Let's make a lot of them. Like a lot of them. Wow. And then let's fucking make them spheres. So you can be like, instance this piece of geometry on these points. Fuck. Instance on points. Boom. Slap that in there. And we just have like a thing that we want to put on them. So we can just be like, I want a fucking sphere in here, please. Slap this sphere all over the place. Holy shit, that's a big sphere. Let's make it a tiny sphere. Maybe bigger than that. There we go. Okay. Now I have a bunch of fucking spheres in here, and we can color them according to those same rules. So we can be like, set material, I think? Yeah. Okay. So now if we look at this in this view, we start to see a bunch of balls floating around in the cube, right? Where they're kind of like black in the corner, red over here, green over here, and blue at the top, right? And what I found was if you just kind of rotate this a little bit, look at it from the corner, it's like, that looks a lot like HSV, my dude. Like, a lot like HSV. Blender's geometry notes, a man of culture, I see. Yeah, so what I look at this and I say, okay, we are seeing some sort of like hexagon that looks a lot like HSV, right? And if I think about this a lot, or not that much, it starts to make sense, right? If you like, because what you have here is you have like an axis along this edge that is the like red axis, right? Red axis, green axis, blue axis. And so when you were like when you're like sampling a color from this thing, you're just kind of saying like, okay, I have some red value, multiply that by the red axis, some green value, multiply that by the green axis, some blue value, multiply that by the blue axis. If you rotate all of your axes a little bit, that concept is like still the same, right? So like over here, you have like maximum green plus maximum blue is like cyan, right? And maximum red plus maximum blue is purple, and maximum red plus maximum green is yellow, right? And white is maximum all three added together. So I believe what HSV is doing is they're essentially just taking like this hexagon and they're just kind of like rounding it out a little bit, right? And by rounding it out, you are kind of saying that in each of these 6 quadrants of the hexagon, if I take like the angle that I'm pointing in any direction, I could have to like interpolate between like the red and blue. in that thing, right? So I think, I'm saying all this because I think if we just display our color picker as a fucking hexagon, we don't have to do any math. I think all we have to do is multiply like red by the red axis, green by the green axis, blue by the blue axis, add them up, and then I think that we get something that looks kind of sane. Then all we have to do is like to display our little like circle thing, right? This circle. We basically just have to slice this thing at some point, right? You can kind of like normalize all of your values by the distance from like this bottom corner over here to where we are, right? So we say like if we are looking at like maximum lightness, we just like I guess squish everything down and so I haven't really thought about it all the way. But like we'll see how it goes, right? We'll see how it goes. Cuz like yeah, the idea here is that these corners are actually like brighter than these corners because they have like more oh, I don't know. We'll see. Do you want a Desmos graph made for HSV? No. I think that I want to see what happens if we just freeball it and like figure it out. So anyways, that's kind of the plan arena. I want to make a hexagon, try to display this thing in some way and see what that looks like. Because fuck doing what is sane and what everybody else expects, you know? That's boring. So let's make a source GUI color picker sig, and we'll start making a widget and see if we can like come up with something sane at all. How do we make widgets? Let's just like copy our button widget, I guess, and then we'll move forward from there. I'm quite proud of the graph myself. I figured it out last year or so. I'm not like not interested in it. I just feel like it will twist my view of the world, you know? So I like it's kind of like when you watch like Harry Potter the movie and then you read Harry Potter the book and you just can't get like, you know, Daniel Radcliffe out of your head when you think about Harry. You know, it's like by exposing myself to it, I'm worried that I'll twist my current view of it. I kind of want to see how far the current view goes. Okay, so we make widgets that generate actions. Surely our color picker will generate an action. And our widgets conform to this widget type, which has a render function, a d'init function, a get size function, and like input handling, as well as what does update do? Update like takes in the current. Oh, updates for like relayout. Okay, yeah, okay. So what are we going to want to display in this thing? We are probably going to have. Let's just start by like trying to draw the hexagon. Okay, so what is the like angle? We need to like find our RGB vectors. Maybe we'll start by just making some sort of OpenGL program to use. So I think that we can get away with probably using our like our existing like just render me a fucking square program, and then we can make like a custom fragment shader on there probably. Yeah, let's do that. So maybe a triangle makes sense for now. A hexagon, a circle, a square. I don't know. We have to start somewhere. So let's just render. Let's render a square. We'll render a square and we'll come back. So that means we need some sort of like program to run. Okay. Let's just kind of like const GUI is equal to import GUI zig. Const action type is unknown. Const widget is GUI widget. Okay. Now all of this stuff's happy, and then we'll just kind of figure out the rest as we go. So kind of get rid of all this shit. All this. This will probably be something like this. Probably something like this. We probably do have to stash the size somewhere. There's no internal label to update in this world. We probably will want to handle input at some point, but for now we'll just return null. And we will want to render something at some point, but for now we'll just do nothing. Okay. Make button is gonna be like make color picker, and here maybe it'll just be color picker in it. We'll figure it out. Okay. Why is he pissed here? Return. Oh, because I spelled return wrong. There we go. Now he's pissed off about a lot of stuff not being used, so we'll just kind of like go like this. We'll ignore this, ignore this, ignore this, ignore this. Okay. We need an allocator type, I guess. Which means that we need to import stud. And pixel size needs to come from GUI pixel size. Okay. We need to kind of stash the pixel size somewhere. So here we'll say we have a size. And when we are asked for the size, we'll return that thing. Okay. Let's just comment out these lines that are unused, and then hopefully we can get back to compiling soon. Hopefully. Unused function parameter. Okay, we'll do it this way. Because I'm sure that we are going to want to use ourselves somewhere. Pixel bbox he also needs. Okay, so we'll do this, and input state. Okay, hopefully that's everything. Unused local const itself. Okay. So now we can go into our demo and try to construct this GUI picker, or this color picker in some way. So let's just kind of put it before our lorem ipsum text. So we'll say const color picker is equal to, we need to import the color picker, probably in our GUI. We're gonna be like pub const color picker is equal to import color picker zig, nice, nice. And then down here we'd be like, give me a GUI color picker with a UI action initialized with nothing for now. And let's shove that into our layout. All right. Alec and color picker. Okay. He's mad because we do need to return a thing from the thing. So let's just say for now we take in a. Maybe we'll just like. Yeah, we'll take in a width and height. Fuck it. We'll take in a width and height. Width U31, height U31. Okay. And we will be like, I guess we need an allocator as well. And we need to construct our widget type. So our widget is going to be like something that has a context and a vtable. So context is going to be the color picker. And the vtable is going to be widget vtable. Okay. Which means we need a color picker. So we need to like alloc create a self. Is that Vim, insane speed? Yeah, it's Vim. And our color picker is going to have to be like, we have a size. It's the only thing that we have right now. Size equal to width is equal to width, and height is equal to height. Okay. All right, all right, all right. Now do we compile? No, because we didn't pass these things in on init. We have to pass the parameters that we want to use. It's a true. Alec 400 by 400. Let's not think about it too hard right now. Okay, so now we have a 400 by 400 space. That's way too big, by the way. Let's do like 100 by 100. But it's not rendering anything. 100 by 100 is too small. Let's do 2 by 2. Why 31 and not 32? U31s can cast into I32s very cleanly, right? Because an I32 can represent all U31s, but an I32 cannot represent all U32s. So when I'm switching between signed and unsigned types, I just drop my unsigned by one power of 2 because it's just like easier to work with. Okay, so on dinit we need to free ourselves. True. So we just say alloc destroy self. All right, and now let's try to render something. So we have this like, we call it a plane render program. It's actually just a program that renders any fragment shader on any set of triangles, but we called it this because we initially used it to make a plane. So let's start by using one of these. So we're gonna be like, make me one of these with an allocator. And what else is taking? A vertex shader, which we can use like our default vertex shader. And a fragment shader, we are going to use our own. So we'll say color picker frag. Okay, and is that it? Is that all it takes? And an index type, which we'll just pass null. Fuck that shit for now. And then we'll be like, renderer is equal to this. We'll kind of start there. We need to make a fragment shader. So can we just take our like default plain fragment shader and just kind of copy this for now. But instead of doing whatever the fuck he says to do, we're gonna do our own thing. Color picker frag. We're gonna be like, I don't care about jack shit. All I care about is making this thing white for now. Okay, we just want to see some evidence that we're doing anything sane. We have a renderer here, which is a plain render program. I guess we'll kind of pull that out. Like this, okay. And really, this is gonna live in like shared state later, but for now, we'll just construct one per color picker because I don't give a fuck right now, you know? Okay, then this is gonna be like that, and then on render now, we should be able to be like, here is our bounds, and here is the window size, I think is the order of things here. And I think that we have some sort of like utility class, utility function to basically ask us to transform what would normally fill the screen into these bounds. I think it's like util widget to clip transform. Yes. Bounds, window bounds. Okay. And now we should be able to just call like renderer self, renderer render with the default buffer, which we need. So we need some sort of like vertex buffer, which is going to be like a plain render program buffer, which we're just going to make the default. Because the default buffer just like fills the screen, which is kind of convenient in a lot of ways. So we'll just use that. We can pass that thing back in. And what else does he need? Surely he needs other things. He needs some empty arrays that we're not going to worry about right now, and a transform. Okay, so that should make a white box, kind of like wherever this thing is supposed to sit. Instead, he crashes. Because this is supposed to be vec4, not vec. That's true. Boom, white box, baby. Let's fucking go. Okay, so now we have to figure out how to like make our color picker. So what do we want to do here? I think that we want to... Okay, we're basically trying to visualize like a cut through this space. Right, so we're kind of trying to take like some plane that is like rotated by like some amount, right? We're just kind of like trying to like shove this shit through here, right? Obviously this thing isn't rotated correctly, but you get my point, right? We're trying to like get some view of this, and then as we get like farther away, we see less of this thing, is kind of how I'm imagining it. I guess... Yeah, sure, fuck it. I don't know. We'll see how it goes. We might want to like normalize this stuff in some way, right? To get to like full white, if you move all the way up the lightness chart, maybe it does make sense to only be able to make full white if you're all the way up. That's kind of weird. Maybe we clamp every value such that the length is what we want. That seems kind of reasonable. So we're going to want like some circle question mark? Maybe. We could render a circle. Or we could render our hexagon. I don't know. I haven't really thought about this all the way. Let's render a hexagon. So we could render this thing in a way where we might be able to formulate this where we get everything we want for free. If we render a hexagon like this, right? So we kind of like, how does this, jeez, holy, okay. We render kind of like this thing as like a fan, and we just set this coordinate to green, this is green, this is red, this is blue, this is max blue and max R, this is max green and blue, and this is max RNG. We can kind of get like all interpolation for free here. This thing is going to need to have some sort of independent color. Maybe instead we just set... We could like interpolate ourselves in the fragment shader instead. How would we do that? We have some sort of like lightness value. Okay. And we have our red, green, and blue vectors. Red, green, and blue vectors. So blue is pointing straight up. Okay. I don't know. We'll like this. Red is pointing what I assume is 120 degrees rotated from that. So that's like negative sine 30. Hold on, let's just sine 30. We want in degrees. Sine, no, fuck, sine 30. So 0.5, that makes sense. So this is negative 0.5 on both red and green. Okay, and then the x is just going to be the cosine of 30, I guess. So this shit show. Okay, so we want one to be on the right side, one to be on the left. Okay. And then I guess we're going to have our plane that we are rendering in. We can just take our point, any point that we're on here. So if we're at like negative 1, 0, right? That's right. Or yeah, that's here. This is 0, 1, right? So if we're at 0, 1, we're at maximum blue. So that makes sense. If we're at negative 1, 0, we're kind of like at some distance between green and blue. I guess if we were to draw a circle in this thing, hand wavy, this is like the maximum distance we can be. So green's probably like here and red's probably like here, right? Anything in this range is like 2 green or 2 red. So if we're like over here, we basically want to calculate how much green we have and how much blue we have by projecting this onto the green vector and onto the blue vector. Is that possible? Yeah. So if we're half green and half blue, we're kind of here, which means that we can project like this and like this or something. I guess it's kind of like this and like this, right? You draw like 90 degrees. So our like maximum red and green is like, or yeah, if we have to go like 90 degrees, we have to go like all the way out here. Or if we want to get maximum. So there's something fucked up here. I thought that you could just like project onto the red and blue vectors, the red and green, or the blue and green vectors, and like see what happens. Maybe we start there and then we figure out why that's wrong. So we take like our position, and we just say like R. We'll call this red axis, green axis, and blue axis. And what happens if we just like fucking do like red is the projection of us. So us is like literally our UV position. So it's like just like literally like UV onto the red axis. And then you like onto the green axis. And the blue axis? Like what the fuck does that do? That seems like it does something. But instead he's like, what the fuck are you doing? True. It's not at all what I was expecting to see. Oh, because UV is 0 to 1. Fuck. We want, in this world, we want negative 1 to 1. So we're going to do like UV times 2 plus 1. We'll just call this like vec2 clip chord is equal to this. Minus 1.0? Yeah, minus 1.0. Really? Oh, because I didn't use the clip chord? Okay, so that's starting to look like something, right? It's definitely starting to we see some like green and red. Now, I'm surprised that there isn't kind of more yellow in here, right? That's surprising. But I guess we'll figure it out as we go. We might discover why we need to use HSV. That's what we might discover. Now, we need to remember that there's some sort of like 3D aspect to this, right? These guys aren't really supposed to be rotated like in 2D space from each other. They're supposed to be rotated in 3D space, and we're supposed to be on some plane in 3D space. Hand wavy. So we have like some lightness value that we're supposed to be using. So can we say that the lightness value is just added to this stuff? Let's look at the cube again. So let's say we have like a lightness of 1.0. What are we expecting to see here? We're expecting to see, I guess we want to see like our direction, our proportion of red scaled up, right? So if we're kind of like on a plane that's kind of going through like the dark section, we want to multiply our red value by the lightness, right? So the maximum lightness is 1.0. Sure. Let's see what happens if we do that. So we'll say that our lightness, lightness. Sorry, we're thinking. So our plane render program, we need to say that we want to interact with the lightness value in some way, which means that we pass in like an index value here somewhere. Who else uses this thing? Can we look for an example? We want some sort of like index type. Yeah. Okay, so in here we have like an enum that says like color uniform index, and we're looking for lightness. Boom. And we pass in this type here, and what happens is like as he constructs this program, he's going to like walk each element in this enum and be like, yo, is there any uniforms that match that name? If there are, then I will put them in some buffer somewhere, and you can like use those later. So we can be like, yo, I want to set the thing at the lightness index, which is gonna be like color index dot lightness as index. Boom. I want to use this thing. What's my other thing in here? Reserved uniform value has a sorry, other one. Val. Okay, so we say like val is equal to float equal to self lightness. Okay. So that means that we need to have some sort of like lightness value, I guess. That needs to get updated from somewhere. So maybe this comes for now. Can we just like render a float dragger inside this thing? Does that kind of work? Let me think for a second. Float dragger. He has a way for me to get some sort of value. Then like what happens? He emits some event on update. We have like a render function. That's like a maybe. That's a maybe. We could try it. We could try embedding a float dragger inside here. So how would we do that? Drag widget is going to be some sort of like widget that returns a color picker action, I guess. I don't know. And this is literally just gonna be like, give me the fucking float back. Okay. Yeah, so when I drag you, give me a fucking F32. Okay. Then how do we like make these drag widgets? What is it called? Drag float? Sure. I guess we kind of have one of these already. So we can be like, drag widget is a GUI drag float make widget. We need allocator. We need some way for him to get the value. So that means that we need some sort of like, we need to like provide him our lightness value. So I guess we do this. Color picker dot drag widget is equal to this thing, and then we can use like color picker dot lightness, like this. Lightness we can just predefine to like 1 pointer or something. I don't know, man. We'll figure it out. We'll kind of mess around. Surely we need like an error defer here for like alloc destroy color picker if we fail, and then here we probably need to do like an error defer of renderer dinit. Okay. Okay. So what else goes into this thing? I think we're just gonna slap a pointer on this thing, and if that doesn't work, then we'll have to figure out what to fix. On drag, we need to like generate some sort of event. So here we're gonna be like, action generator is some structure, and I think that it's expecting like a get val. No, generate function that returns a color picker action. Yeah, he's looking for something like this. He's looking for something like this. So here we're just like, yo, give you an action generator. This is because like theoretically this widget could return any type of value and it just happens to be returning exactly the float we want. We want a drag float style. Okay. That we pass in here. We're getting somewhere for sure. We're looking for label state and squircle renderer. All of those things come in. Label state is GUI label shared label state, and squircle renderer is GUI squircle renderer. Could we just do like this? Import squircle renderer. Okay, that's a lot of stuff. But I think that does what I want. I think. So then when we render, we basically need to render this thing somewhere. So we kind of need to do like, we need to like take our bounds and basically just take the bottom. Is gonna equal like, take like the first 50 pixels, 20 pixels even. I don't know, I don't give a fuck. Maybe we take the like self drag widget get size. Yeah. So we say like the drag size is this thing. We take our bounds and we say the first thing is from like his size, drag size, width, height. And the right is from the left plus the width. And then we could fucking render this thing. That seems reasonable. We're not going to be able to interact with it anyway, but that should at least render the widget inside. We're going to have to like play with that later, but I think this will work. Did we forget to pass like label state to this thing? I think we did. Okay, let's kind of see how that goes. Let's see how that goes. So this is going to pass in all of that other shit, which was the drag float style label state squircle renderer. Okay. Fuck. Expected this, found that. So here we probably want everything to be const. Everything to be const. Okay, let's try that. Fuck. Drag float, expected this, found that. Oh, so this should be like this. We don't need to make him a pointer. Which means that wherever the fuck we just passed it in, here, we should dereference him. Fuck! Not marked pub. Not marked pub. Probably on generate here. Okay, get val in F32. Oh, right. So here we need like... we can fix that. So here we just tried to say, here's like a pointer to a float to use. And he's like, I don't know how to deal with that. But we can make him know how to deal with that. He's expecting a thing that is like a function, like has like a function get val that you can call. But in reality, we don't need to do it that way. We need to do it that way. So hold on. Hold on. We can like pass in whenever we try to call get val on this thing. We can turn this into like get val on the val retriever with as a pointer probably. Yeah. And then we can get crazy. We can get crazy and do some zig meta programming. So I think we already did this like on the label here. We can kind of do something similar here where we're like, well, hold on. Drag float. We go like, okay, so this is our val retriever is literally any type. If our val retriever has to be a pointer because we pass it in as a pointer, and the type is, you know, the type of his child. All right. Now we say like, if it's a structure and it has get val, fucking call that shit. Otherwise, if it's a pointer, we don't need to deal with any array stuff. We literally just go like, if the pointer child is an F32, then we just like return that shit. Like this. Otherwise, everything fails and we say val retriever must be a float 32 or a structure with a get val func method that returns an F32. Instead, it is this. Okay, so now what's he pissed about? Get text 174. Oh, get val, my bad. My bad. Expected F32 found star F32. Whoa. Oh, because we were, yeah. It's like a double pointer here. If P, wait, how is this working at all? Compile log val retrieve. Like, what the fuck is this thing? Can we just like T here? Like, what the fuck is happening here? He's getting a star 30 F32. Oh, yeah, I see. So this is like literally double pointer. And then else if it's like just a float. That's the other case here. F dot bits is equal to 32, I think. Return val retriever dot star. Okay. Now we can pass it a constant thing, a variable thing, or not. Okay, so we are not seeing the dragger here at all, but at least we're compiling, which is a big win for us. So why the fuck not? Why the fuck not? Color picker. So on render here, we're supposed to be calling it, oh, because we render our thing on top. Right, so our bounds have to be the, our bounds, like, remaining is bounds, and then bounds top is equal to, plus equal, remaining top is plus equals the drag size height. And then we use the remaining bounds here. Yeah. Tell me that's not gonna work. Okay, sick. So now we have our thing here. We can't interact with it in any way, shape, or form, but we can fix that. So that's just like on set input state, we call like bounds input state. Here we have to basically split out this stuff into a function that's like get drag bounds. Okay. Which is going to take in the drag widget. Okay. As well as our bounds. Which is a pixel bounding box. And then we need this here as well. Boom. All right. Okay. So now we can be like, const drag bounds. Get drag bounds given our drag widget and our bounds. Wow. We'll just do this. It's fine. It's fine. So now we can be like up here. We can be like, get me the drag bounds, please, and we'll just call like self drag widget set input state with the drag bounds and the input state, and then that should we do need to like say like if this thing asks us to change our lightness value, we change our lightness value. Oh yeah. Oh yeah. Uh-oh. This didn't work the way I wanted it to. Why the fuck not? Oh, because we lost the render. That would do it. We do need to render the thing that we want to render. We're getting crazy out here. Okay, so it's now just not changing. That's not good. That's not good. Is that because we passed in our lightness here? We passed him as a pointer. Interesting. Is it because when we set input state, we're not returning? If this thing is called, it's supposed to, maybe we're not returning an action from the drag float thing. Can we like just log here for like stud debug print lightness changed? Let's just start there. Fuck. We do need to write down what it changed to. Okay, so that's working, yet the widget is not seeing the change, which means that this like passing of a val retriever is not doing what I expect. Which is kind of interesting. Oh, maybe we have to call update. We do have to call update. That's probably why. So on our update, we have to call. What is this thing that comes? Oh, this is the window size probably. So we're gonna like self drag widget update with the window size, I think is what this is. Fuck. Okay, we got there. Okay, so now this thing changes our lightness value. Hell yeah. Stacking of widgets, working correctly. Let's go. And now we can just do something with this. So in our thing, what did we say we want to do? We basically want to like scale everything by the lightness. I think that's what we said we wanted to try. Okay. Okay. It's doing something. Doing something. Okay, now the thing in the center is still always dark. And that's because our thing needs to be 3D. That's what we were initially saying. So let's try to draw this out, right? If we have our like blue, green, red, right? We tilt it on its side so that we're kind of looking like kind of up through the middle here. We want to make it so that our blue axis has a length of 1.0, okay? And we need to be in 3D space somewhere. Somewhere in 3D space. I haven't really figured out where. Okay? Presumably, so you have we want something where where the angle between like we have like some like the ground is like here, right? And we want to make it so like this angle and this angle and this angle. All the angles to the ground are the same. I don't really know what that is. I didn't really think this far. So if you have a cube and you place it on its corner, you have a cube, place it on, you have a cube. Boom, 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 boom. Right? We're making it so that this vector is up, right? Like the vector from corner to corner. So we have this vector corner to corner, and we know that that's 90 degrees with the ground, right? Which means that we can pretty reasonably like find the angle between this and the blue vector. Yeah, we find the angle between this corner and the blue vector, then do that 90 minus that is going to be the distance, the angle to the ground, right? Sure, let's do that. Okay, so we have like 1, 1, 1. And we are trying to find the angle between that and 0, 0, 1. How do? Cross product? Dot product? A dot B is equal to AB cos theta, right? So then we have like 2 is a dot product, right? 1 times 0 plus 1 times 0 plus 1 times 1 is 2. So then we have A dot B is equal to 2 is equal to AB cos theta, right? And then we know that A, like one of these is 1. So B is 1. So it's just A cos theta. And then, so we do 2 over A cos 2 over root 3, I think. I'm pretty sure that's the angle. We can try it. 2, and let's go into like sines mode. 2 divided by 3, but with a square root. Is there no fucking square root? Oh, wait. 1.15. Which is what? In radians? Or in degrees? So we want to do like, that's over 3.14159 times 180. 66 degrees. So minus 90. 24 degrees ish. I wonder if that's right. We could check. If we were like in Blender, just try to like how do we do this? Rotate this in a way that looks kind of like approximately correct. Like, what is this angle here? We have, is one of these angles on any axis? No. How do we like measure this angle? I guess we could check if we get the same answer for all 3, which we would have to. I guess we do this for like multiple of them. And then, is it not pi over 4? I do not think so. I do not think so. I could be wrong there. Here's what we'll do. We will make we will take a ball in Blender for sanity, right? We will shrink this thing down and we will put it at x equals 1. And then we will apply all transforms. So if we were to rotate this thing over x equals y, maybe, by like 45, 90. What is his position? Is that how this works? I don't know if that's how this works. Geometry is fucking hard, man. Geometry is hard. So let's do duplicate this thing and set its position to 0, 1. And then duplicate this thing and set its position to 0, 0, 1. Okay, then we rotate, do this rotation. Okay, we need to do some sort of like extra rotation. Okay, yeah. This is fun, guys. This is how you do math, right? You just kind of like fucking freeball it. Yeah, I do think that this thing needs to be rotated over x equals y. Why isn't that doing the rotation? Oh, it's x equals negative y, I think is what I want to go -1. Yeah. Okay, here we go. So we get this thing so that they're all kind of like lined up a little bit. Like, yeah. Like maybe something like this. This guy, right? That's kind of what we want. To some extent. They're all kind of like even-ish. Even-ish. Apply transforms. And then look at the center of this thing. This guy's got this position-ish, right? Obviously this isn't like quite correct, but whatever. Can we like rotate all of these guys so that his like X and Y position are like, oh, they're always close to, fuck. Like, let's just rotate this guy so that his X is like here, so we can like think about it in 2 dimensions. Just hand wave. We're just trying to see if like, we're just trying to sanity check our answer. So here we have like, x over z. Tan theta is z over x. Okay. Sure. Import math. Math.atan2 z. No, we want math.atan2 x z. And then we want like, this isn't probably in radians, so divided by math pi times 180. 55-ish? That's not what we got. 54-ish. 54-ish is probably the right answer. So how do we get there? I mean, that looks like 50 degrees too, right? Like that kind of like lines up. So what did we do wrong? We have 1, 1, 1. We know that 1, 1, 1 is perpendicular to the ground. We want to do 1, 1, 1 dot product with our blue axis. Okay. AB cos theta. What's this 2 here? Why do we write 2 here? Because the dot product is 1 times 0 plus 1 times 0 plus 1 times 1. Okay, 2 is equal to AB cos theta. Length of B, this is 1, length of 1. So the length of this. Did we do the length calculation wrong? Oh, did I? Whoa, 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 whoa. Oh, this A cos is like inverse cosine. Okay, yeah. Math A cos 2 over math squared 3. Let's just make sure. Math domain error. Is that not A cos? What is he complaining about? Okay. Why is it mad? I must be doing something stupid. Reduce the problem to 2D, it's equivalent to 1101, so 45 degrees. I mean, clearly not, right? Looking at this, it's not 45 degrees, right? Like, this is lower than 45 and higher than 30. I'm positive that it's not 45. Because you can't, you're rotating in 3D space. So you can't just say it's, like, all of these guys need to be 90 degrees from each other. Oh, well, they're not anymore, but they were when they were here. Yeah. I'm like almost positive it is not 45. Why can't I do this? Is like A cos not what I want? Is that why? Math cosine Python A cos. Am I like fucking stupid? I guess we can just check. Math cos 50, 40, 55. Math.acos. This should give us back. Oh. Blah, blah, blah. 55 times divide by 180 times math.pi. Yeah, why is this not giving us back the same thing? Am I stupid? What am I missing? Isn't it A cos 1 over square root 3? That's what I thought. Is it not? Oh, did I 2 over square root 3? That's a very real possibility. Because the length of this is 2. Yeah, so what, yeah. Oh, no, you're right. You're right. It's not. The length of this is root 3. I think. A cos is only defined from -1 to 1. Oh, is that what it is? Why -1 to 1? Am I stupid? Shouldn't it be -pi to pi? Am I just using the wrong fucking function? Oh, okay, sure. No, yeah, that makes sense. Then have I done something really stupid? Angle between 3D vectors. I'm pretty sure I did the right thing. Let's just punch the number in somewhere. Let's just... These are 2D. 3D. 1, 1, 1, 0, 0, 1. Okay, so this lines up with what we saw in Blender. I don't know why I got it wrong, though. That's kind of annoying to me. It's kind of annoying to me. Is annoying. But this lines up. So we could just use this. We could just use this for now. But I guess I should fucking understand why what I did was not correct. I should understand that. I should understand. So, dot product, some of these things. Yeah, that's what I did. Where's the like here? Ooh, did I get the formula for a dot product wrong? Oh yeah, it's here. A dot B is equal to AB cos theta. Is it because is A cos and arc cos the same thing? Arc cos Python. Is it different? Yes. God damn it. God damn it. Okay. Yes, use cos equals arc cos equals cosine and then 1. So do I do like math, Python, inverse, cosine? Like, is this not something that is like easy to type in? We have a cos function which returns angle radians. Am I stupid? A cos is arc cos? Yeah, so then what's the difference? Why is this not working? The dot product between the vectors is 1, not 2. Oh, that's a really good point. That's a really good point. Thank you. Yeah, I'm just a dumbass. I was adding stuff and I was like, 1 plus 1 is 2. But it's not. It's 1 times 1 is 1. Wow. I actually fucked up on like the brain dead stupid part. Thank you. Okay. So does this do what I want? Times 1 over pi. There we go. Okay. Thank God, dude. This is why math is so hard. It's just like, okay. So we now know that our axes should be rotated by 54.7 for this many degrees off the ground, right? So how do we do that? We know that in x, we know that like, okay. So let's go back to doing some math now. So we know that blue is pointing like straight up, right? So he's gonna have like a y position basically of like 1, 1, 0, 1, right? This is like the blue direction. And we need to rotate him up towards our face by this many degrees. Right? So we want to go like, I guess that means if he's like on the ground and we're trying to go up, we need to rotate him such that it's like this now, right? So this is his new y is sine that thing. The new x is cos that thing. This is the new z. This is the new z. This is the new y. And the x value stays the same. Yeah. Yeah. Sure. That makes sense. So we have like angles equal to this. We have math sine of angle. We want the length of this vector to be 1, right? So we know that this is just his z coordinate. And this is just his y coordinate. Okay, we finally got there. We got to one of the 3 vectors. I guess we should probably punch those actually into Blender just to make sure that that looks sane. Like we just take like a cube and we shrink them down. Let's just like sanitize this at least a little bit. Oops, that's fine. So we take his z, we take his y. Yeah, maybe. Sure, that doesn't look like crazy wrong. Sure. Okay. And then we just need to like rotate this 120 degrees. So z value is going to stay the same no matter what. Z value is going to stay the same no matter what, and we're just trying to get his x and y now. Here. And we already know that this is like we already did this math a little bit. This is like, this is negative 0.5. And we just need to multiply by the length of his like length, his xy length only, and then we should get the right answer. Yeah. Okay, hold on. We can get there. We can get there. So this is the ground angle. Okay. Then we have the can we like, yeah, so this is z is equal to this for all of them. Fuck. Ground angle. Then the blue y is math cos ground angle. And then the bx equals 0. Okay. Don't you want a color cone instead of a color cube? I think no. And we're going to find out if the answer is actually no. I think I want a color hexagon. I think. But we'll see. So okay. So now the xy length of these things is by times by plus bx times bx square rooted. Fuck. Math squared. Okay. Right, so the xy length of these things is lower than 1.0 because a lot of the length of this 1.0 length thing is like taken by the z-axis. Does that make sense? If we rotate this thing, his y position. Whoa, what's going on here? Oh yeah, his y position is like 0.57, which lines up with what we got here. Okay, cool. So now we just do like the red x is equal to cos of 30. So can we just be like, what is 30 in radians? Rad 30 is going to be 30 divided by 180 times stood math pi, right? Not stood, just math. And does that make sense? 30 over 180. Yeah. Okay, cool. So rad 30 is that, and then we do math cos rad 30 times xy ln. Oh. That's surprising. Okay, so these are x and y coordinates. So our x coordinate has now turned into 0.5. That's interesting and fun. Okay, so we have like rx is equal to cosine of green and x are going to be the same. So this is this. Ry is the negative of this. And then the green x is just equal to the negative of rx, and the green y is equal to ry. Okay, so hopefully we have z value, we have gx. Let's do z value, bx, by, gx, gy, rx, ry. Okay, these are all of our numbers. Hopefully that gets us somewhere. Let's just comment these out for now, I guess. And stick them over here. Okay. Okay. We're losing our fucking minds, guys. We're going a little insane. But that's okay. This is fun. I'm having fun. Okay, R, G, B all have the fucking same Z value. Blue axis, 0, blue Y. Fucking this thing. Green axis. We can probably get away with negative 0.5 here. And this. We should actually probably sanity test here that all of these lengths are still 1. There's like a real chance that we fucked that up. Because we're shit at math. We'll admit it. So can we do a quick sanity test here that like you know, this times this plus this times this plus this times this is 1. Let's go! We're not that stupid! Okay. So now we have our rotated on their sides red, green, and blue vectors. So now we need to basically take our coordinate and say that he's a vec 3 of the UV coordinates plus the lightness value as the Z coordinate. Okay. And so now, fuck! No dot vec 3 vec 2. Vec 3? Wait, shouldn't everything here be vec 3? Oh, I have some vec 2s over here, my bad. That's not crazy. That's not fucking crazy. So as we go towards 1.0, I would think at 1.0, everything should be bright. But maybe it's because we're not clamping. Like what we're seeing over here has to be greater than 1 on some axis, right? It has to be. Maybe not. Yeah, I wonder what the fuck we're seeing. Okay, so the bounds of this thing. Where is white? Do you need to go up to 2? Yeah, I would have thought that white is right here in the fucking middle, right? Wouldn't we have thought that? Because if white's in the fucking middle at 1.0, shouldn't we have... Oh, do we need to add lightness in somewhere? Huh, wait, what's happening here? I don't think we're supposed to multiply by lightness here anymore, to be honest. Not that that matters at 1.0, but that is going to change the answer for sure. What is this project, Sparrow? I'm making a image editor, which means that I need to make a GUI framework. Which means I need to make a color picker, and I didn't just want to use like a default color picker because like I want to make a color picker that I understand what is happening. So obviously that's where we end up. I guess here at like lightness 0.0, we're seeing something like pretty fucking stupid, where we're kind of seeing like I suspect we're not seeing the full distance here. Yeah, what at 0? Let's go into Blender. Let's go into Blender. Let's take our RGB cube again. Let's make another RGB cube. And let's go into this view and just kind of and then is this 1 okay, let's oops, we missed an axis. Is this 1 yeah, it is. Okay, so let's turn this into some colors again. give me some color, please. What did we do? We did this, and then we took like the RGB position. And we shove that into here. We give this like a little 2.2. Okay, and then I want to like rotate this. Why did I fucking close the other thing? That's fucking stupid. So what do we want to do? We want to rotate this so that we are going 54.75 degrees over the y equals x axis. Right? Other way maybe? Okay. And then we want to rotate this whole thing around z so that blue is pointing like up on y or something. Which one of these corners is blue? Did the color change when I rotate? Oh, it's fucking using the oh, the fucking material is using the world coordinates. I want him to use the fucking object coordinates. Can we do like it's like object info, world coordinate. There's a way to like do this transformation. I just don't know what it is. I think stream is lagging. It does feel like it's going at like, I am fucking losing dropping bit frames. Holy shit. Holy shit. Let's see. Pause play. That's annoying. That's annoying. I guess. Oh, fuck, man. Oh, it's not coming back. Maybe it'll come back something. Is it like bandwidth test? Oh, I don't want to do a bandwidth test on stream because I will immediately leak my IP. Okay, we'll give it a little bit of time, and if it doesn't come back, then we will lose our fucking minds, I guess. I'm just going to... Let's hope it recovers. I'm gonna keep going a little bit because I don't want like VOD viewers just be like, what the fuck? How do I do like object coordinate in Blender shader? Texture coordinate? Yeah, that feels more like what I want, huh? No, oops, object, not camera. There we go, okay. And then are my RG and B looking like at the same height? Yeah, they are. It's just because it's not orthographic projection. Okay, so what was I doing this for? I was trying to decide something. Let's look at this demo again and see. Oh, I was trying to decide if these corners here, like what color I expect them to be. Because I'm doing like a projection of like, oh, well actually, this is a good thing to look at. First of all, didn't I rotate it so that the, I wanted to rotate it so that blue was on axis? Like this? Right, so this looks a lot like when I do this. This looks a lot like that, which is kind of interesting. But we are not seeing like the full blue and full red sections, which kind of means that this point feels like it's like farther than 1.0 up. Yeah, I'll try restarting stream. Could not access the specified channel on stream key. Please double check the stream key is connect. Oh, now it's just full dead. Fuck. I'm gonna keep going for the VOD, and you'll just have to check it when it comes up. Sad. Sorry. Oh, wait. Wait. It's back, maybe? Are we live? Are we live? No, I don't think so. No, it's... Oh, wait. Are we back? Are we back? Wait. Are we back? I'm hearing myself, dude. Ah, it's pretty bad. Oh, that sucks. That sucks. I want to keep going. Yeah, I'm gonna keep going for VOD. Frowny face. Oh, wait, maybe? Oh, God. It keeps fucking toying with me. Yeah, I'm gonna keep going. It keeps toying with me. Guys, are we up? Video's choppy, audio seems bad. Yeah, that sucks. Okay, I'm choppy weekend emitter. I think I'm just gonna keep going, and I apologize to live viewers, and I think that it's just like Twitch is fucking me. I don't know, or maybe my internet's going down. I don't know, but I want to keep going. I want to keep going. So, I'll leave the stream on. You guys can watch if you want. But apologies. Apologies. I understand if you don't want to. Okay, so this point, where is the cursor? Where is the cursor? Here he's got a Y position of 0.8. So everything, the maximum red value and the maximum blue value should be within here. So why am I not seeing that? Right, I would think that I should be seeing maximum blue here. Oh, I guess what's happening is I am taking this point here and projecting onto the blue vector. So I'm kind of going like X, Y, Z. Wait, yeah, it's like up here. What if I clamp this shit? Blue is straight up, right? Straight up in Y, yeah. So when I'm going to like the very tippity top of the screen, oh, are we back? It looks okay. If I go to the very tippity top of my viewport, I'm pretty sure that we should be like all the way up here is like where the top is. That's what I think should be happening. I could be wrong. I could be wrong. I'd be interested to try clamping this stuff to 0 to 1. I would be interested in trying to clamp and see if that changes anything. So how does clamp in GLSL work? You're cropping? But I don't think I should be. That's what's bothering me. You know? That's what's bothering me. So this is value min max. So like if we just go like on all of these, like, does that change anything? No, because what I thought I'm making is a square like this. This is what I thought I was making. Right? Which should go beyond the thing. And also, we should be like way the fuck up here. So if we're projecting this value onto the blue axis, like, I would think that we should be getting maximum blue value. That's what I would think. But I do not believe I'm getting that, which is confusing to me. So why? Clip chord. UV times 2 minus 1. So it should give us negative 1 to 1. Then I guess because we're probably projecting onto the other axes as well. But if we're clamping from 0 to 1, okay, can we only look at the like, can we just write 0 in the other coordinates? Right, if we were at 0 for red and 0 for green, we only look at blue. Is that okay? So this gives us something that goes like, at brightness 0, we see a transition of 0 to blue, and then as we go up, we're kind of seeing like more blue make it into everything. Okay. Why? I don't understand. I guess. Can we look at the geometry again? So I guess that's kind of like moving this plane from here all the way up. And what it's kind of saying is as we go from 0 to up, somehow the bottom half of this thing is getting more blue because we're projecting onto this axis. It looks okay, but it's not doing what I expect. And I don't understand why. So the projection, there's like an arrow going like along this blue axis, right? And like for a given point on this plane, I guess we're kind of projecting like, yeah. So the center right now, the center of this plane at 0, 0, 0 projects onto like the very bottom of the thing. So the projection is 0 here. As we move up, the projection is getting higher and higher and higher on all 3 axes in the center, which makes sense because we want the center to go from 0 to white as we move the lightness up. Now, the side effect here is that the stuff back here on the red side of the cube, red-green side of the cube, is also getting projected onto blue now as well. But that makes sense. Yeah, I don't think that's what we want, huh? We want it to get like more and more red and green. We want the blue amount on this bottom half of the thing to stay 0 no matter what. And that's why this idea of just projecting onto the red, green, blue axes does not work. I see. And so that probably explains why people do HSV instead. I see. I thought that I was going to get clever here. But this... Yeah. So what do I want? I basically want to make sure... I guess I want to project onto the 2D projection of the red and blue. That fixes it. Which is what I was doing initially. So if I like flatten these guys out so that they don't kind of point up at all, then the projections will always go straight down, and I will never project onto the blue stuff on the top half of the screen from the bottom half of the screen. And when will I see like a maximum? I guess we should see. Hold on, let's think about this. So the other thing that's kind of weird here is like maximum red and green here. We can't just do a dot product of that because that dot product would have to come down here. Because I thought that if we just add red and green together, that's how we end up down here, right? Right? So like if we have maximum red here, maximum green here, we add them together, we get to the maximum red green point right here. That's what we're trying to display. So I guess theoretically at any lightness value, we are trying to display at each point I don't know. I guess it's all starting to make sense. Like the idea of HSV is totally reasonable, right? If you were just to kind of like bring all of these points together and squish them in the Z axis. Can we take the bounding box center? We like literally just like Why is this not doing what I want it to do? Oh, because I missed one. That's why. If you just took all of these and you squished them like this, that's kind of what we actually want, right? That's kind of what we actually want, which is a lot more like HSV. So I think we're just reinventing it, which is kind of funny. Okay. So I guess in this world where we have like a cone like this, a fucking hexagonal cone, you can no longer get to like this point by adding these 2 points together, right? Which means that you have to work in rotations. I think. Is there some sort of like clever mathematical way to like get from here to like here to here? You could basically work in like parallelogram space. But I think we're just getting to the point now where HSV makes sense. We have just reinvented HSV, right? Because now we're like, okay, we might as well work in rotations. And if we're going to work in rotations, we might as well kind of like turn this shit into a circle. Okay. Okay, we got there. Slowly, but we got there. And now we've gotten to the point where I'm okay with just using HSV. So fuck everything we just did. Fuck it. let's just we'll be like Q is going to be like fuck this lightness value for now. We're gonna be like Q is going to be, I guess, atan to uv.x uv.y, and then our saturation will be our distance from the center. So lightness still makes sense as like distance from bottom to the top of this fucking pyramid cone shit. And so how do we turn this into RGB? We say, let's just pretend right now that we are at lightness 1.0. We will only think about lightness 1.0. If we are at the 1.0 in the red direction, so we basically want to lerp from red to green. We want to lerp from red to green as we move from the red angle to the green angle. So we want like red angle is like 120 times math times pi. Is there a pi constant in GLSL? Here, they have this. No. Okay. We'll just, okay. 120 times pi over 180. Okay, this is the red angle. This is the red angle. Blue angle is going to be 0. And the green angle is just the red angle times 2. So we basically say if Q is greater than red angle and Q is less than green angle, we do like some sort of like lerp. I think that we can do something tricky. Like if we start with, we're basically trying to get some sort of function that goes like from 0 to 1. We want like red to go, I guess, kind of like this, and green to go like this. Yeah. No, sorry. Wrong. We want red to go like this, and green to go like this. Yes. So we're lerping from 2 down to 1 and then clamping. We're lerping from 2 to 1 and clamping. So we say, I guess we do like hue f mod hue 120, except we want, I guess we'll just call this like red angle. Is there an f mod in GLSL? GLSL mod. Sure. So we're like, give me this out of that. And we want to do like A is going to be lerp from 2 to 0 given dist. I guess we want like dist. We want like the hue over red angle to give us like the amount between 1/3. Then we want to take, we want to be like mod this by 1.0. Yup. Okay. I guess we can do 0 to 2. And 2 to 0. Does that make sense? Sure. So we're going to have something that goes from 0 to 2, 2 to 0. Then we clamp both of them. Yep. And then we set A and B depending on, like, if we say, if we're between red and green, we go like fragment is equal to vec for AB 0 1.0. Else if hue is greater than or equal to green angle, we do with green and blue. Yup. Otherwise, we do blue and red. Yup. Sure. Fuck it. That seems reasonable. Only greater than? It doesn't really matter. Doesn't make a difference, I don't think, but sure. Fuck! Vec 2 cannot be assigned to Vec 3. Where is that? Oh, here. Fuck! No function with A10 too. Really? Really? A10. Oh, okay. Are we doing some wonky color space, or is this HSLV? Well, we started trying to do some wonky color space, and then we reinvented HSL when we got there. I think lerp is mix. That's fucking wrong. Clip chord here. Oops, wrong fucking unit. Whoa. We've done something fucking stupid again. Classic us. Did we get A and B backwards? So if we are going from, we're trying to, this gives us something that goes from like 0. Oh yeah, this should be going from -1 to 1. You're right. I think. That looks still stupid, but slightly less stupid. There's a lot of blue showing up when I wouldn't expect it to. So, if we're between red and green, can we do like else discard here? I'm doing something I don't expect. To 2. I don't believe that it should be -1 to 2. That doesn't make any sense to me. Okay, so this is like the green area. And if here we have green, we are expecting some red to start showing up here, I would think. Which means that red has to start showing up immediately. So I guess I was wrong about this. Like, I guess we do expect red to start showing up almost immediately. And I guess, do we really expect like a lerp this way to work out? I think so. Okay. And then... No, wait, no, hold on. I want green to stay active the whole way. I want green to stay active the whole way. I did do what I wanted. I want this to show fucking maximum green all the way over. So if B is going to the green channel, I want this to go 2.0 to -1. You're right. You were right about -1 to 2. You know what? I can admit that I'm wrong. I can admit that I'm wrong. Okay, so then why are the rest of these not being discarded? That means that this is not doing what I expect. GLSL A10. This is YX. Not that I think that should make a big difference, but this is still, again, not doing what I expect. So why the fuck not? Hue is greater than... Oh, else discard. Did I lose that? Okay, wait, no, that is doing what I want, I think. Else if hue is greater than or equal to green angle, we do the same thing with G and B. Is it mod or abs for the distance? I want the distance to be like something. Yeah, I guess this might be negative sometimes, huh? I want it to be like, how far have I gone from like one angle to the other? You know? But yeah, there's a chance that's wrong. There's a pretty big chance that's wrong, actually. But let's just kind of see what we get first. Okay, yeah, so now we fucked something up again. But you're probably right about the fact that this is going to give us some value between negative pi and pi. So I think if we just add pi there, kind of fixes it. Okay. So now we go from like green to blue, and then blue is like getting like hard fucking set to red there. Are things going in like the wrong direction for me? Like, why am I seeing any red in here? Or any blue? Okay, so yeah, so I should be going green, red to green, and green to blue. And clearly I'm not seeing that. Right? I guess it could be if, like, for some reason this is backwards, but I don't think it is. Yeah, I don't understand. I don't understand. Because I'm just doing something fucking stupid. I understand that much. So, here I'm saying I want to go from -1 to 2. Yeah, so there's 3 segments. There's 3 segments in our little section. We're trying to go on green, flat, down. What are we trying to do? We're trying to be like, as I rotate, at the midpoint, I want there to be maximum red and maximum green. So I want, like, from here, green, here, red. I want, like, increase in red to here, decrease in green to here. Right? Here I want max red, max green. I figured that much out. I figured that much out. Here we already have maximum green. So here we're just like, green doesn't fucking move. Right? Then green decreases linearly this way. Which makes me think these lerps are fucking stupid. This is probably why they have like 6 rotations in all of the code I've seen that does this. Yeah, because what I want is like green, stay, now go down, red go up, red stay. Wait, so there should be 2 segments here. Which is why I had -1 to 1 before. Right? Except it should like it should be like 0 to 2. Lines up with my understanding again. But that didn't look right, so why not? So here we're above the red angle. Red go up, 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 up. So at the red angle, red should be capped the fuck out. And green should be 0. Then as we progress towards green, we should get more and more green until they're both 1.0 in the center. Okay, yeah, that seems right. That seems right. Okay, now if the hue is greater than the green angle, we should start with green maxed here. And we should start working towards blue, so blue comes up, 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 up. Let's see what that looks like. Oh, wait, there we go. We fucking got there. We fucking got there. Okay, so the last thing is, again, A, B, like this. So it's just that the A and B were inverted from how I was expecting to use them. That's a fucking color picker, dude. Now we need to start scaling out from the center here. Right, I think we just have like a constant color in here. So as we get out from the center, we have to make it so that things in the center are more white. So flip chord, we basically want to take the length of the thing at position dist from center, right? This is going to be the length of our clip chord, right? We can be maximum 1 away, but in the center we're 0. So our saturation should be like, so as we get towards the center, we get more towards just like 1.0, 1.0, 1.0, 1.0, right? But we start at the fragment shader if we're far away. So I think we just kind of do this. Backwards? Yeah, because the distance, so yeah, backwards. Oh, hell yeah, dude. Okay, now all we have to do is fucking factor in the lightness thing. So I guess this is just everything here. It's multiplied by the lightness, I think. Guys, we're fucking gods. We are so okay, except alpha needs to be this only needs to apply to X, Y, and Z. So now we decrement the lightness and we get to black. Guys, we did it. We reinvented HSV. I don't really know if I understand. I feel like I'm seeing like lines here that don't really feel very good. I think that probably we need to clamp this. If length is too long, can we discard? Okay. And is that what a color picker looks like? I guess like in that Blender color picker, we're seeing something very similar where we do see some like lines here on like the midpoints. Okay, keep this up. I mean, that looks pretty similar other than the fact that we're not round. So I guess we got there. Do you want to check my solution now that you have yours? Yeah, I'm pretty down to see yours now. I am down to see yours. Now that we've just reinvented the same thing. like I felt pretty confident when I started. I was like, surely we can do something smarter. But now I don't want to. All right. Yeah, that sure is. Okay, so what are these? Yeah. So we did just this is just the right thing. Yeah. I don't know what this X and Y are though. But yeah, you are correct. Also counterclockwise and red not in south direction. Yeah. Do I care? I think the yeah, I'm not sure I care. Not sure I care. Okay, so now we have like Artifacts are operated. Hey bud, what's up everybody? Um, what's up? Okay, we are working on a GUI framework because we have a massive set of not or of like a terminal diagnosis of not invented here syndrome. But we are kind of working on this like image editor. Where we, you can do some stuff. Let's just like, throw some draw stuff on the screen. We can like put some text on the screen. We can like, I don't know, we can like cut out a picture of hold on. We can like, take a picture of someone and like try to cut them out a little bit, right? Boom, 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 right? That creates like a cutout, and we can like create these things. We can like shove these things into a composition where we can be like, give me this and like, I don't know, a like blue blob or something, right? This is what we're working on. Right, we can compose these things together. Bing, bang, boom, right? It's not really very good yet, but it's something. It's something. We're getting somewhere. Now we at some point said we want to use IamGUI as our GUI framework because we need like some sort of stopgap, and then we were like, at some point we are going to like do something else, and that something else is that we are doing our own GUI framework because we don't want to be limited to what other people have. Right, we want to be able to like kind of any idea that we come up with, we want to be able to make it, and it's also fun to say that we made like a GIMP replacement with zero dependencies. That's just like a funny thing to be able to put, in the README, right? So that's why we're making this GUI framework. And the GUI framework's looking like okay. What you walked into was us trying to implement this like color picker, where we started with the idea. That you could take a RGB cube, put it on its corner, and just use that cube as is as our color picker. I was wrong. We basically reinvented HSV by mistake. We basically just got to where HSV is, and so that's what we were seeing on the screen here. I guess the next step here would be to, when we click somewhere on the screen, we need to pick that color. Which means what? What does that mean? We could either like duplicate the RGB logic from the shader on CPU and run that shit again, or we could render the RGB thing to a texture and then sample it, or we could probably just read 1 pixel from the texture. Is that like a thing you can do? Read 1 pixel from OpenGL texture. Or like, can we like, you could like render 1 pixel. You could do it that way. Just to save like HSV duplication, I'm okay with just doing this twice. I'm okay with it. HSV is like a pretty known algorithm. You could store the color in a storage buffer. Yeah, I think that fuck it. We just do it. again. Sure. Actually, I wonder if you could like cheat. Hold on, let's look at this again. You know what's kind of interesting here? Is there's kind of one upwards and one downward section for each color. So like if you wanted to get crazy, you could implement these things as one linear function with a clamp and an abs, which is kind of funny. But I'm not gonna do that. I'm not gonna do that. Okay, you know what I'm gonna do? Instead of sampling the color, I'm going to just draw GL read pixels with an XY width height. Redoing fast calculations on the CPU is actually the more responsible solution. GPU readback is bad. Okay, yeah, that's kind of what I'm thinking. That is what I'm thinking. I was like, if it was like something where I was going to be using lots of pixels from the GPU, maybe then reading it back is okay. But I think, yeah, I do know that like reading back from there is like a big bottleneck. Yeah, fuck it. Fuck it. We'll just be like, we'll just redo it on GPU or on CPU. So when we sample this thing, first of all, let's fix our sizing so that our size here is like self. We want our size to be like square after the drag widget, right? We need to fix that like little squishy. So I guess for now, I'm just gonna be like, return that the width of this thing, I think we're fair to just say that it's the width that we asked for. But our height needs to be adjusted with the height of the drag bounds of the drag widget get size height. Okay. So now that should fix the fact that it's like not fucking square. Yeah, look at that. Look at that circular circle, baby. Look at that circular circle. Okay, let's just sample from here. So when I click on this thing, we're gonna be like, we have our drag bounds. So we basically just take our bounds and we say the color bounds is gonna be the total area of our widget. But we're gonna be like color bounds top minus equals drag bounds calc height or something. Fuck it. This is what we did before. We should probably do like proper layout of these things. Probably the drag value should live outside the color picker, to be honest. Maybe, or maybe we should use some sort of like global padding style or whatever. But we'll do this. This is fine. We are going to basically convert the color bounds such that we can use the same math probably that we use in here, so we can just copy fucking paste it. So let's do like a pixel to RGB given the bounds of the pixel B box, or the bounds of like the circle. So, oh fuck, oh I did way too much. Okay, we have the red angle, green angle, blue angle. No main anymore. We are in where we want to be. We do have like a clip cord here that comes from UV. So our UV we need to convert. So I guess we'll be like UVX is the bounds dot calc width. We take its bounds. I guess we take like our position. We need our position. So this is going to be like some sort of pixel pause, which I don't think exists right now. I don't think we have that concept, but we should probably make it. Pixel pause. X, Y. Sure, fuck it. Fuck it. Okay, so I guess we have mouse pause, which is what we use for this type of thing everywhere else. So we should just do that, actually. We should just do that. Fuck this pixel pause. Get the fuck out of here. Okay, so we take some sort of like mouse pause. And I guess we want to take like the bounds The bounds are all in like integers, so I guess we need to convert those to floats. So we say like const bounds height is a f32 float from int of bounds calc height. We have the same for width. Okay. Then our x position, we need to be like, we need us, mouse pause x, relative to the bounds left, which needs to be a float as well. Gross. Okay, and then all of this is divided by the bounds width. This is our UV x here. And our UVY is the same thing. Top here, over bounds height. And then OpenGL space is flipped. So here we need negative of all of this, I'm pretty sure. Okay, so then here they want the clip chord is just going to be UVX times 2 minus 1. We do the same for Y. We could be working in vec2s here, but I'm not, so what you going to do? The dist from center is just clip X times clip X plus clip Y times clip Y, a little Pythagoras, squirted. Okay. Then what? If distance from center is greater than 1.0, that means that we return a color value here of null. We say there's no color. We are outside of the fucking circle. Okay. Seems reasonable. Okay. We say we have a Q is probably like stud math a10 2, which needs Y and X. So this is clip Y, clip X, time plus stud math pi. Boom. I think this is probably F mod? Mod? Does this work with floats? Maybe stud math F mod? Remainder? Remainder? Is there, like, am I fucking mental? Is there a, like, Zig F mod? Does this exist? F mod? Mod? At mod? Yeah, it does seem pretty non-existent. Is there like a way to extract the like remainder portion of a float? I don't really see it. Am I crazy? I really thought it would exist. Maybe in stud math somewhere? You could do something like x minus 4. Yeah, that's true. I guess we just do that. Yeah, that doesn't seem crazy. So it's just apparently mod f exists. Oh, thank you. And this will say, give me the 2 parts. So I just want the fractional part. Thank you. Is that what I did here? Why did I do that? So I took the hue over the red angle. Oh, because I wanted to get it in 3 segments. I see. I see. Okay. Then this is stud math clamp on A and B. Mix is stood math lerp in this language, and then our lerp takes the ABT, so we're chilling there. This is and then mpi here is stood math pi. Okay. Fragment here is just the return value, so return r is equal to b, g is equal to a, b is equal to 0, and alpha is equal to 1.0. This is the same, except it's 0, b, a. And then this is the same, but it is a 0, b. All right. Oh, and then we need to multiply by the lightness. So we actually need var ret is a color undefined. Then we do here ret equals on all these, and then ret times equals lightness, which doesn't exist, return ret. So we need to do like G and B. I'm Steve O. Thank you for this for the tier 1. Much appreciated. You've been here for a fucking while, dude. Here for a while. Okay. Unused local constant on blue angle, true. And then here we just go like pixel to RGB with a lightness. And like, I don't know, what the fuck else is in here? Pixel RGB, mouse pause. I guess we do like if we put the mouse down, we calculate this, I guess. And then we take our color bounds here. And I guess we say if we get some color, let's just log it. Color. Kai Scott, thanks for the prime. Much appreciated. Much appreciated. Why is my computer fucking... There we go. Okay. So now hopefully when I click on this thing, we get like sane RGB values. Instead we get nothing. That's super cool. Love that. I guess we probably... Well, yeah, why the fuck is this not doing anything? Oh, because I didn't save. Classic. Classic. Okay. Still not printing though. Could be that this is not doing anything. Stood debug, stood debug print, and then can we do like mouse down? Lock. Let's do that. Let's see what we do need to write down that we want to know where we put the mouse down. Let's see what happens if we do that. Okay, so that's happening, which is good, I guess. So why is this not doing anything? Stood debug print distance from center is this number. So this distance from center is always big? Why? Am I using the mouse pointer? I am. So I'm saying like, here, give me my X position relative to the left side of this thing over the bounce width. Okay, can we like log the UV and X UV? Where does the programmer wash his dishes? Where does the programmer wash his dishes? You can tell me. Async. God damn it. I'm upset that made me laugh. That's fucking stupid, but good one. Good one. Okay, so here we have 1, -0.5. Oh, because the fucking UVY is relative to the bottom because... wait, why? I don't understand here. Let me think for a second. So we have like our mouse position. We want our position relative to the bottom. Bottom is bigger. Is it like... Is it this? it seems like that's still going to be wrong, but this is -1. Something about this is all wrong. Maybe it's the bounds that we made for this thing are wrong. Pixel to RGB. So here we need to add our top, not minus it. Okay, that'll help. Okay, so now this is -1 and this is 0. That's a lot better, but so that means that we can go back to whatever the fuck we were doing before. But we do want to be relative to the bottom, not the top, because our UV coordinates in OpenGL space are upside down. Okay. Okay, so this is very red. Here, very red. Very green. Very blue. And this is... We did a mix here for the... We forgot to do that. We forgot to do our lerp here. So we need to... Std debug lerp. Nope, std math lerp from the value of vector... Like, what does this thing want? 3 F32s of ret.r, ret.g, ret.b, and like 1.0, 1.0, 1.0. So I got that backwards. It's the other way around. Ret.r, ret.g, ret.b. Then we have, I guess we could just like triple lerp. Maybe that's easier. Even though that's fucking stupid, it's fine. It's just easier. It's just easier. All right. So now we click in the center, we get like something that is very close to 1. We click on the yellow, we get something that looks like max green, max red. We click on the blue, we get something that's max blue. Looks like everything's working. We crank this down to black, and we get like something that's very close to black no matter where we click. Okay. Cool. Cool. Can you replace 1.0 with lightness? Yeah, probably, right? Seems the same. Seems like you are correct. No. No, we cannot. I changed my mind. Because, this is changing, like, this is assuming, if the lightness is 0. Oh, wait, maybe it's fine if we do the lerp 3 times, though. I'm not sure. We could check. Yeah, why do I think that doesn't work? Oh, because we never want to lerp towards 0, except... Yeah, here it's like if it's lerped fully towards red, we still want it to be 0. You know what I mean? So I think that the equivalent is to write lightness times lightness here and lightness here. You know? Because like if you are like red 1.0 and you're lerping to lightness, there's actually no lerping towards the center. Like if you imagine the thing as a cylinder, this lerp brings you towards the center, and the times lightness brings you towards the bottom, if that makes sense. Sergeant Pepper, thank you for the raid. What's up, you guys? You're catching me just at the end of the stream. We're working on our little GUI framework in Zig, and we have made a little color picker. Look at this. Wow, I click on this and it says red down here. Wow. Wait. Why doesn't it say red? Oh, because I didn't. It's sorry. We have to max that shit out. Now it says red down there. We were going to get farther today. That was the goal. But we spent a lot of time basically reinventing why people use HSV color pickers. We were trying to play around with the idea of like using like a 3D cube and like dot producting onto the red, green, and blue vectors and stuff like that. But we learned why that was stupid. So I think we spent way more time than I wanted to on this, but it was also really fun. So I'm not really that upset about it. Not too chucked. But sorry for the raiders. We are going to peace out now. If you want, if like you're not going to have much context here to say. Usually I say, if you like what you saw and you want to see more, there's a YouTube link in the Twitch description, right? Where you can see what we're working on right now, organized by playlist. We're working on this GUI from scratch, but there's lots of other cool stuff in here, right? There's like we're working on this image manipulation program. We've done some font rendering, QR code decoder, like GPU, virtual machine implementation. We're doing a lot of fun stuff, so if you want to check that out, it's there. GitHub link in the Twitch description. Where this code will end up under the Svimp repo eventually. If you're watching on YouTube, there's a Twitch link in the YouTube description. You should swing by and say hi if you're on if you're online between 12:30 Pacific time and 4 o'clock Pacific time. But yeah, I was gonna say all that, right? But you new raiders are gonna be like, I don't have any context, and so I apologize for that. But it is what it is. YouTube, peace out. Twitch, let's find someone to raid.